Automotive safety is in the spotlight for today's vehicle manufacturers, and proper tire inflation plays a leading role. Car and truck safety, fuel economy, and handling performance are greatly affected by correct tire inflation, but few owners bother to check their tires regularly. In order to check tire pressure more easily, vehicle manufacturers are installing sophisticated tire pressure monitoring systems, commonly known as TPMS, on many new cars and light trucks today. These systems monitor tire pressure while driving and alert the driver if air pressures become unsafe. Recent federal legislation, known as the TREAD Act, has mandated the use of TPM systems in the United States in most new vehicles with the gross vehicle weight of less than 10,000 pounds. 100% compliance is required by September 2007. In order to service the growing number of TPM systems already in the market, we developed TIPS, or the Tire Inflation Positioning Switch, a patented universal diagnostic tool designed to communicate with the sensors used by most TPM systems in use today. Before we discuss the benefits of TIPS, it is important to understand the fundamentals of tire pressure monitoring technology and how it affects you, the tire service professional. There are two basic technologies in use today. Indirect monitoring systems work with the vehicle's ABS system and do not require the use of sensors or transmitters. They are reset by simply pushing a button on the dash. The technology that has gained the most popularity and meets current federal regulations is the direct TPM system. These systems incorporate the use of wheel-mounted transmitters or sensors. There are two sensor mounting types used. The first incorporates a metal band or strap to attach the sensor transmitter directly to the inside of the wheel. The second uses sensor transmitters connected to the inside of the valve stem, which can be generally recognized by their metal valve stem. Both sensor types transmit information such as air pressure, temperature, and sensor ID to the TPM computer module in the vehicle. When the vehicle is at rest, most sensors are designed to sleep in order to save battery life. Generally, these sensors transmit information to the vehicle's computer only after the vehicle has achieved a certain velocity for some specified period of time. From time to time, it is necessary to wake up or trigger the wheel sensor while the vehicle's at rest. For example, after a tire change, rotation, or when installing a new sensor. There are three different triggering methods and sensor types in use today. The first are sensors that are designed to trigger when exposed to a powerful magnetic force. These sensors are only installed in aluminum wheels because steel wheels will absorb the magnetic energy that is required to trigger them. The second are continuous wave sensors that are designed to trigger when exposed to a continuous electronic signal for a specified period of time, usually 4 to 7 seconds. The third are pulse-modulated sensors that are also designed to trigger when exposed to an electronic signal. However, in contrast to a continuous wave type, these sensors are looking for a unique electronic pattern or protocol before triggering. Many automobile manufacturers have electronic protocols that are unique to their vehicles. The end result is a marketplace filled with multiple sensor protocols that will all have to be triggered. While these three methods are used in the majority of sensors manufactured today, some sensors can even be triggered both magnetically and electronically, with both modulated and continuous wave patterns. That could mean the need to purchase multiple tools to communicate with a vast array of TPM sensors. Well, the TIPS is designed to work with all three types of triggering methods used in the industry today, and it can be updated to accommodate new sensors as they become available. This patented technology is built into every TIPS tool. There's no reason to purchase multiple sensor triggering tools when a TIPS is all you need. We've talked about how tire service professionals can now trigger TPM wheel sensors as needed, but there's more. There are two radio frequencies in use today, 315 and 434 megahertz, which communicate information such as tire pressure, tire temperature, and sensor ID to the vehicle's TPM control system. This radio frequency link enables low tire pressure warnings to be communicated to the driver in one of two ways, as mandated by the federal legislation in the TREAD Act. One indicator